Solve now logarithmic inequalities. Example 1. Log of x to the base 2 is greater than 3. So to solve this one, you have to make it exponential, meaning the exponential equivalent of this is x is greater than 2 raised to 3. So x is greater than 8. So what will be our solution set then? This one is from greater than 8, meaning from 8 up to positive infinity. Okay. Example number 2. So example number 2, you have log of x minus 5 to the base 3 is less than or equal to 2. Okay? So this one is x minus 5 is less than or equal to 3 squared. So this is x minus 5 is less than 9. Solving for x is less than 9 plus 5. X is less than 14. So we have the solution set, negative, infinity, 14. We will be using bracket here since this one is less than or equal to. Now, another solution set may be this one. Remember that this one should be greater than 0 based on the definition of logarithmic function. That is log of x to the base of b is equal to 1. Remember that x here should be greater than 0. So we cannot get a value of this if this one is less than 0. So that will be greater than 0. So that is x minus 5 is greater than 0. So that will be x is greater than 5. So the solution set here is from 5 up to positive infinity. Okay. So getting the intersection of the two, when we say intersection, this one is the symbol, we have to get what is common to them. And the common to them is what? By the way, this one is a bracket, this one. So therefore, you start from the least, which is 5, and then 14. Okay, so this is the solution set of this logarithmic inequality. Okay? Example number 3. We have log of x minus 3 plus log of x less than 1. There's no base, meaning this is base 10. So this one is plus, meaning we can multiply them. That is log of x minus 3 times x is less than 1. Writing it in exponential form, this will be x squared minus 3x is less than 10 raised to 1. So x squared minus 3x is less than 10. This results to quadratic inequality. That will be minus 10 less than 0. Okay? So let us factor it. This is x minus 5 and x plus 2. So this is x minus 5 equals 0 and x plus 2 equals 0. So we need to get test points so that we can find out the solution. What do I mean by that? So this one is x squared minus 3x minus 10 is less than 0. So x is equal to 5 here and x is equal to negative 2. Using the number line, we have 0. This one is positive 5. 1, 2, 3, 4, 5. And this one is negative 2. So you have negative infinity, negative 2, you have negative 2, 5, and you have 5 positive infinity. Let's get test points from here. So it's negative 2. Let us try negative 3. So that will be negative 3 squared minus 3 times negative 3 minus 10 is less than 0. This will be 9 plus 9 minus 10 is less than 0. So this is 18 minus 10 is less than 0. 8 is less than 0. This one is false. So meaning this is not a possible solution. Next, what about negative 2, 5? Let's get 0 since 0 is in between negative 2, 5. So that is 0 squared minus 3 times 0 minus 10 less than 10. That will be 0 minus 0 minus 10 less than 10. Negative 10 is less than 10. So this one is true. So this one is a possible solution. Next, what about 5 positive infinity? Let's get 6 because 6 is here. Okay, so that is 6 squared minus 3 times 6 minus 10 less than 0. So that will be 36 minus 18 minus 10 less than 0. 36 minus 28 less than 0. This one is 8 less than 0. This one is false. So this is not a possible solution. Okay. Next. Remember again the definition of logarithm, that this one should be greater than 0. So we have x minus 3 should be greater than 0. So x is greater than 0. So you have now these choices. Negative 2, 5. And then, what else? X is greater than 0 plus 3. X is greater than 3. So if we will represent it using interval, this will be 3 infinity. So we have 3 infinity. And then the last one is x there. So that will be x is greater than 0. This one. So x is greater than 0. How are we going to represent it? This is 0, positive infinity. 0, positive infinity. Okay, so these are the 3 possible solutions. So let us get now the intersection of these 3. Let us draw a number line. This one is negative 2, positive 5. This one. Okay. The other one is 0, 0, positive infinity. Okay. And the third one is, of course, 3, positive infinity. 3, positive infinity. Okay. Meaning to say, this one is their intersection. They have this in common. Therefore, our solution set will be 3, 5.